Welcome back to the bench. Today we have a Commodore 64 power supply for restoration. This is my favourite type of power supply for the C64. It's the one that's got the well, it's basically a chamfer, it's 45 degrees. This is by far the easiest one to repair. If you look at the back here, you have all the fuse ratings, and you can see that it has 2 fuses, but there's no fuse or fuse holders. That's because the fuses are inside. And the good thing about the fuses being inside is it means that the bottom is screwed and not glued, which is a big help to us, because that means that we can easily unscrew it. And then we can get in and have a look to the inside. As far as I know, this is the only C64 power supply that is screwed at the bottom and not glued. These bits here always snap off because they're just thin little bits of plastic there. So we can see here that these are our fuses. So I don't know, it looks like 1.8, but I think that's 1.5, is it? What the fuse rating is supposed to be? 1.6 and 2.5. So the 1.6 is on the side of the AC, and the 2.5 is on the side of the 5-volt line. So what we're going to do is we're actually going to take out this PCB, take off the fuse holders, put them on a new board and replace the whole thing. I have made this board, which is basically a clone of what's in here. It's not exactly the same on the back, but it's pretty much does the same function. So we need to get this one out and populate this and put it back in here. Now, I know what you're saying, but it's potted. Yes, it is potted. But unlike a lot of the other C64 supplies, the transformer and the circuit board are potted separately from each other. So it is possible to get this board out, even though it is potted. And I'm going to show you how. First thing we need to do is get rid of this cable. I advise just taking a quick photo so that you know where the wires went, because yeah, if you do what I did and make a replacement board, then you need to know where to put the wires back. Okay, so our iron is warmed up, so it's just a case of, we're not too worried about cleanup at the moment. If we need to clean and solder up, we can do that afterwards. But I advise using a fairly wide tip and a good heat on here, because these are big pads on here. And yeah, it's just a case of desoldering the wires. I've already taken a photo of these on another supply that I did, so I know where they all go. Okay, so next we're going to want to take out these, the copper wire coming from the transformer. These are a little harder to get out because they actually go over the board, through and then to the back. So we'll need a pair of pliers. And what we'll have to do is to first of all kind of soften the solder up and then bend this back a bit. We're not too worried about damaging the board because yeah, we're not going to reuse that. Okay, so that's our wires out. Okay, but this is still very firmly on there, and if you try and pull this out, it's not going to go anywhere. That potting is down, it's all underneath the heat sink and everything, so it's not going to come out with any kind of ease. So what we have to do is we have to drill some holes in the sides here. So what I have is I have my Dremel, and this has got a 2.5mm drill bit in. I have here, this is a pair of circlet pliers. So what I'm going to do is I'm going to drill a hole inside here on both sides, and then using a piece of wood here so I don't damage the plastic, I'm going to pop the PCB out along with the heatsink and all the potting. And obviously drilling through there, you have to be careful, otherwise you go right through. So what I like to do is I have an old metal plate here, which I slide down here so that when I drill, it doesn't go all the way through. So it would be easier to use a punch just to put a little divot in there to stop the drill from wandering, but the problem is then you're pressing against the side of the case, so you could shatter the case. So what I do is I just do it nice and steady, and okay, that's going to be quite sharp, so be careful you don't cut yourself. I have cut myself, but that was on something else. Okay, so we've got our holes drilled. What we're going to do now is just place our piece of wood here and our circlet pliers in. And boom! And if you heard that big crack, that wasn't something breaking, that was the potting releasing from the casing. Okay, let's do this side now. Boom, and there, you can see it just moved upwards. You just have to keep doing that until you can get the whole board out. Okay, that should come out. It's still a bit stiff, but she's a-coming. Boom, and there we go. So, as you can see, it leaves it nice and clean in there. So we put that to one side for now. And this is the bit we want. Okay, you can see a thin sliver of sheet there. Okay, so there is our voltage regulator at the bottom. We'll just pop our fuses out because we don't want to break those, because we actually want to reuse them as long as they're not blown. Okay, so what we have to do is we obviously need the heatsink because we want to reuse that. It doesn't matter about the holes that we've just drilled in there because nobody's going to see them. So we have to get all this potting compound off. Now you could say, well, why not reuse the PCB, just replace the components? Well, the vast majority of the time, these PCBs just break. They're so old. This part down here, it usually snaps off. I did manage to get one out, whole, and here it is. Well, that's the first one I ever managed to get off in one piece. The rest just disintegrate. So what we need to do is use a big pair of pliers, which I should have right here, and we've got to chip away at this potting compound to get it off. Best is to start here and at the sides, because once you release the sides here and here, then you can get this part off. It just peels off. It's still slightly flexible, but obviously it's also very brittle, so once you get past a certain point it will just shatter. So here it goes, and be careful of your eyes because bits will go flying. And there we have it. And even the rivet chose to come out quietly, which is a bonus because usually you have to drill this out, so maybe the hole or the rivet wasn't the best. Okay, so we have our old board here, so we need to remove our fuse holders. So we're bringing our helping hands here to hold it for us. Okay, and yeah, time to do some desoldering. Okay, so yeah, because there's a lot of copper on these traces, then yeah, it's best to use a decent heat and yeah, a big tip. It also might take a little bit to get through because obviously when they poured the potting on, that also went back onto the PCB as well. So maybe adding a bit of fresh solder will help as well. Yeah, that seems to have done the trick. So these two here. Oh, that one just fell out. There you go. Oh, it's still a bit hot, but yeah, it looks like it just dropped off. And that one too. Okay, interesting. It's still hot. All these ones just pull out. Yep, and yeah. And that's basically all we need from that board. We're not going to reuse it for anything else. So it's Gonski. Okay, so this is my replacement board. It's basically exactly the same function as the other one. Big thick copper tracks, helps with heat dissipation. Okay, and when we put these in, we actually have to make sure you put them in back correctly because there is a little bit of a tab there which stops the fuse from sliding out. Focus, yeah. So yeah, if you put them in the wrong way, then yeah, you have to then go to the trouble of desoldering it again. Just clean any solder dags off those, make sure they go in nice and easy. Okay, so we've got new bulk capacitor. I don't like tantalum, so I replaced it with a normal electrolytic for tantalum. We have our 4 diodes to make our bridge rectifier. And we have our resistors. What I like to do with the diodes is not to put them directly hard onto the board, but leave them up a few millimeters. That way it basically gives them a bit of clearance so that they're not directly on the board, so they're not heating the board up, and they'll obviously cool down quicker if they're standing in the air rather than directly on the board. So yeah. Don't have to be too fancy with these. So I always like to start with these diodes first. Okay, and what I want to do is I want to leave them kind of about there, just so there's some good air gap clearance. And yeah, I find the best way to do that is to put it on something like here. It might be a bit too much, that. Just hang them over the edge of something, bit of cork, so that, yeah, when I solder it, okay, so yeah, you can see there that it's not directly on the board, it has a bit of a clearance so that you can it can, yeah, have some free air, so to speak. Yeah, to make sure I did solder that one in the right way, which I did, obviously. Side cutters. So yeah, now we just need to do our other three. Okay, so here is our 5-volt regulator, and what we need to do is we need to bring back our casing here. Solder from the bottom, and our heat sink. And what we need to do is we need to dry fit them, because obviously we need the regulator to line up with the hole, and then we also need to know how far in, because if you put the regulator all the way in like this, solder it up, you've got two problems. One, the hole won't line up. Two, you won't be able to get the rivet in. Trap for young players. Okay, so what I do is pop our heating in. We got a bit of a dag there because of using the screwdriver as a blunt instrument. So let's see if we can just get rid of that off of there. We don't want that interfering with the height, which it shouldn't really do anyway. Okay, so this is our heatsink, which we will put in there. Our regulator will just slide it in there at the moment without soldering it, and then just drop our board in. Okay, using a thin screwdriver, just line up the hole. Alright, we can see we're going to have to bend the but it's slightly at an angle because, yeah, when they drilled the holes to put these in, they were all different places. You know, some actually have 3 different holes drilled in a line here. This particular one just has 1 drilled in, which is helpful. But yeah, so we can see here that we need to, we can look down there and you can see, yeah, you've got about 3 mil, 2 to 3 mil sticking out there. So that's how far you need to put it when you solder it in. Right, okay. So what we need to do is get a bit of heating compound. I like to put a bit of heatsink compound on here. Okay, and then we need to bring it in our rivet. So obviously we need to rivet it back in. And I have an old school rivet gun. So if you don't have these and these, then yeah, maybe you know somebody who has one you can borrow off, because obviously if you don't use them often, then you're probably not going to have one. So I just like to put a bit of CPU heatsink compound on there, just basically to stop the potting getting in there once it's potted. Because yeah, you're going to have to repot them, because the potting actually, you know, acts as a heat sink. So slide that down. Okay. And now we have to put this at a slight angle. I mean, you can still move it once it's riveted, it's not. There we go. Should be about right. Okay, and there it goes with a snap like that, and we know we've done the job right. Okay, so clean up the heatsink compound. Now, obviously that's sticking out quite a way. Shouldn't be a problem. It depends. Some of these are a little bit different, so as long as you can get the heatsink in and it goes down below the lip where the lid is, it shouldn't be a problem. Just dry fit it again, just to be on the safe side, to make sure that everything then is able to go down into a proper place. And yeah, as you can see, it's below the lip where the lid rests, so as long as it's below that, and the PCB goes down far enough, yeah, that's all you need. Okay, so we'll take that back out again, because we need to obviously solder it. Okay, and we just need to have it about here, I would say, is the optimal place. But what I'll do is I will solder one of the legs first, and then adjust it, and then once it's in place, I can solder the other legs. This bit can be a little bit tricky because obviously you can't put it down. Helping hands are not that helpful in this instance. So yeah, we have to try and, well, just put some solder on there first. Generally just, oops, pop out. Get it approximately to the right height and just tack it in. Okay, yeah, so that's tacked in. You just pop that here actually, just, yeah, okay. I don't know why I didn't think about that before. Use the actual case as a holder. Okay, so, yeah. Okay, so that is ready to go in and be resoldered and get everything back together. But what I like to do first is to test it and to test the output voltage, because you can have variance in these regulators and in the resistors and things, because obviously we need to get it as close to 5 volts as possible. I had one that I used the standard resistors in, put it all back together, and yeah, it was 5.4 volts. So I had to take it all back out and then adjust the resistors accordingly, just to get it down to those kind of volts. So what I like to do is get my fuse, my 2.5, yeah, that's 250 volts, 1.6, so this is the one for the 5 volt. I might as well put the other one in as well, it's not doing any harm. Okay, just bring this in a little bit, yeah. Okay, as you see, it still moves around a bit even with that regulator on there. And clip this on here. What we'll have to do is obviously unclip this first. we need to be able to plug it in to the mains. I wish they'd put a power switch on these things. It would have been so much easier, because you always have to leave it unplugged when you're not using it. Otherwise they just, yeah, consume electricity all day long, which is not ideal. Okay, so we've got that on there. Obviously this is AC, so it doesn't matter which way you put it. It is marked on here, AC in. And that one's just O for output, because, yeah, unfortunately I couldn't get the word out on there on the silk screen. So, yeah. So then we can go ahead and just put that there. We can plug our transformer in. And nothing went bang, which is always good. We can bring in our multimeter. Okay, set it to DC. There, you can see that, yeah, not too much glare. So here's our ground, and here is our 5 volts, and yeah, see what I mean? We have 5.4 volts, so we need to just adjust those resistors a little bit, just to make it go down a little bit. Okay, so we would have put that in the case, then we would have had a problem, because, yeah, it would have had to have been desoldered again. Okay, so I played around with the values of the resistors and ended up replacing the 200 ohm with a 560, and that brings our voltage then down to, well, we put it on the voltage range, it would do, 5.244, which is well within the limits, and that'll drop down a bit anyway once the Commodore is connected, because obviously a bit of draw on there will reduce the power. So yeah, we can unplug that, and now we can reconnect our wires. Okay, this is the second version of the board I did. The first version of the board I made these holes way too small, so I looked at the cable and everything, and yeah, made the holes bigger. But then I found out with this one and some other ones is that the actual thickness of the wires, the conductors used in here, have different thicknesses. Some of them are thinner. These ones are the slightly bigger ones, which means that yeah, they're a bit of a tight fit. Okay, so I have my phone here with the colors of the wires. So it's green, white, and that's our 5 volts and ground. So the green is the ground, the white is the 5 volts. Okay, that is our leads back in. So now what we have to do is get our AC lines back in. And remember, they go over the board and then through, otherwise you'll end up with a lot of extra wall wire, and you're wondering, where did all that extra come from? Okay, so yeah, we just pull it through and then bend it up. And we'll do them all first, and then we'll solder them in. Okay, so just double check our connections are well and truly soldered. Yeah, and they're good. Okay, we'll plug it in and we will test the voltage again, just to make sure nothing went awry, nothing goes pop. But I'm 100% confident that I soldered them in the right place. Famous last words. Okay. Okay, so there's our 5 volts. Just bring it up here. Boom, 5.2. Okay, so that is good. So the acid test is plugging it into our C64 and seeing if she works or whether she has a pop. I have confidence in my work. Just make sure you put the grommet back in the right way because, yeah, it does have grooves on only 3 sides. So I need to bring in my C64. Okay. And I need to get my video cable. So that's for the 64 and the 128. Yep. So video. So I reconnect everything down here. No, I didn't. It's plugged in. The moment of truth. Okay. And contact. Boom. And there we have it. We have a good working picture. Our power supply is working fine. No smoke from the C64, which is always good. So I've been quite lucky. I've actually got several of these power supplies because I've got a few. I bought a few C64s that came without the power supplies. I have another lead for a C64 power supply here. Obviously this model is by far the best one to have. I was lucky and picked these up for like €5 sometimes each, plus, you know, €3 or €4 shipping. So let's say €10 a pop, including shipping. Sometimes you have to pay a bit more, sometimes you have to pay 15, maybe €20 to get one. It depends. I mean, they always usually sell them as not working. Usually they are working, but yeah, I just strip out the PCBs and upload, strip out the PCBs and put new ones in, just as a matter of course, because then I know it's good for another hopefully 30 years. And yeah, the last thing to do is, yes, we do have to repot this because the potting compound will obviously help the heat move from the heatsink to the case and then obviously into the outside world. If you didn't pot it, it would probably still work, but obviously it would get very hot in there and may cause some damage. Who knows? But yeah, I mean, I just pot it, matter of course. I have a couple to do now. So yeah, I was waiting until I had 3 or 4 of them to do, so that I could just make up one batch of potting compound and then just pour that in. But obviously I won't show it here because obviously pour it in, it doesn't make an exciting video. This stuff is, yeah, as I said, it's flexible still, but you bend it to a certain point and it just shatters. So it's just perseverance. It takes time to get the old compound off of there. But it can be done, as I showed. And yeah, when this thing is repotted and the cover's back on and screwed up, yeah, you'll never be able to tell that anything was done to it. I might sign this one inside and, you know, in case somebody in 20 years time opens this thing up, you know, to repair it again. They might see my initials in there, my signature. Who knows? funnier things have happened. Maybe they'll dig it up in 1,000 years and, you know, she'll still work because, you know, it's been maintained. Who knows? Okay, so yeah, I'm going to make some tweaks to this board because, yeah, the last few I had, I've had to tweak the resistor values, so I'll probably change that on the schematic. I may just throw these the Gerbers up on my website, grahamtinkers.com. It's not a very good website, but you know, I haven't really spent too much time on it. I have to manually change the URLs for the videos. It's just basically a feeder site, mostly for my YouTube channel. Plus there's some other bits of information on there, bit of a bio, more information about me if you're interested. You can take a look at that. And then I said, yeah, I probably just tweak this a little bit now and just throw the boards up, and then if you want, you can go and get the boards made yourself if you want to repair your own power supply. And I got these boards made at PCBWay. It's my first order. I did tweet about this a little while ago. Yeah, they're not sponsoring this, so this is not a paid promotion or anything. But yeah, I was like really impressed with the service. I got $5, you know, as a gift for first-time customer, because of their like 6-year anniversary. And I ordered this and another PCB that was from their website, one of their contributors. And yeah, it's like, I think 1.5 weeks, and they were already here after I ordered them, you know, 10 days, I think it was, 10, 11 days. I was really impressed because I just wasn't expecting them. Because I've ordered from other Chinese suppliers before, and you know, 2-3 weeks, you know, which is pretty good when you think about how much you're paying for these boards. You know, I used to do my own boards, you know, with the transfers and the tapes and the pens, and then etch them in ferric chloride and trying to do a double-sided board, you know. And then you had to buy the pins that go through to make the vias, because obviously it's not through hole plated. And yeah, a lot of hassle, a lot of mess. And this is just far simpler. Time to wrap this one up because it's probably going to be quite a long video. So thank you for watching as always. If you liked the video, give me a thumbs up. If you didn't like it, give me a thumbs down. Hit the subscribe button if you want to, and the bell to get notified when I upload new videos.